Today, I'm going to introduce you to the right-hand rule for assigning RNS stereochemistry labels. This is the rule the pros use. This is the rule I use when I assign RNS stereocenters. And if you've taken a physics or a math class, this will flow quite naturally. Hey there, ninjas. This video demonstrates an alternative method for assigning RNS stereochemistry labels. The official OChemNinja method for assigning RNS is the A.R.C method. I invented it, and I have a link in the description down below. The A.R.C method works for any molecule, any orientation, no matter where number 4 is, with no cute hand tricks or trying to visualize three-dimensionality. Remember, friends, that an sp3 hybridized carbon is tetrahedral. One way to think about that tetrahedral carbon is as a really bad inverted umbrella, where one stick is the stem of that umbrella, and the other 3 bonds are the spokes of that inverted umbrella. You can almost imagine holding that stick and twirling the umbrella and watching the other 3 groups spin around. In the right-hand rule method, we're going to put number 4 at the stick of this umbrella, and the 1, 2, and 3 groups spin around as the spokes, defining the RNS stereochemistry. We call it the right-hand rule because it shares the same principle as the right-hand rule that you may have seen in physics or math. For example, the x, y, and z axis in a 3-dimensional coordinate system. If you curl your right hand from the positive x-axis to the positive y-axis, your thumb points in the direction of the positive z-axis. Same thing in vector math when you take a cross product. If you curl your right hand from the a vector to the v vector, the cross product points towards your thumb. And the same thing with the principle of electromagnetism. If you curl your hand in the direction of current around a coiled wire, your thumb points in the direction of the magnetic field. We're going to use that same principle with our inverted umbrella to assign RNS stereochemistry. Like always, the first step needs to be to assign the SIP priorities. This isn't a video about finding stereocenters or assigning those priorities, but I do have a link to that video that I'll put in the description below. For the amino acid alanine, the nitrogen group is priority number 1, the carboxylic acid is priority 2, the methyl group is priority 3, and the hidden hydrogen is priority number 4. Next, we apply the right-hand rule. We take both of our thumbs and we point our thumbs in the direction of the number 4 group. The nice thing about this method is no matter where the 4 priority group is pointed, we can always point our thumbs toward that group, whether it's in the back, in the front, or off to one of the sides. For this molecule, number 4 is on a dash, so we point our thumbs away from us. If you were looking down on a piece of paper, you would point your thumbs away from you. When you do this, when you point your thumbs towards number 4, something very interesting happens. Notice that your fingers curl in different directions on the different hands. No matter which way you're pointing your thumbs, your fingers will always curl in opposite directions. And that curl direction is what we're about to read. No matter where your fingers start curling, if you curl them far enough, eventually only one hand will hit number 1, wrap to number 2, and around to number 3. The other hand would hit number 1, then wrap to 3, and around to 2. Whichever hand wraps from 1 to 2 to 3, that tells you the stereochemistry. If it's your right hand that wraps from 1 to 2 to 3, with your thumb pointed towards 4, it's an R stereocenter. If it's your left hand, an S stereocenter. For this molecule, with my thumb pointed towards 4, it's my left hand that wraps from 1 to 2 to 3. That makes this stereocenter an S stereocenter. Because this is so cross-applicable in math and physics and now chemistry, this is the method the pros use. This is the method I use. If there's a tricky RNS assignment, I'll still put my thumbs towards 4 and wrap my fingers around. Now, I've gotten good enough that I can actually do this in my head. I can actually watch my fingers in my head wrap towards 1, 2, and 3, but this is the method that I use personally. Let's look at 2 other examples to see if we can apply the right-hand rule to those examples. Here are 2 new molecules: Linalool, the primary fragrant component of lavender, and Limonene, the primary fragrant component of citral. Pause the video, see if you can use the right-hand rule to assign the RNS stereochemistry labels. First, we prioritize the groups. The alcohol is 1, the alkene is 2, the chain is 3, and the methyl group is 4. For limonene, the alkene is 1, the ring around to the alkene is 2, the other side of the ring is 3, and the hidden hydrogen is 4. We take our thumbs and we point them towards the number 4 group. For linalool, that would be towards the right side of the page. And then I check to see which fingers curl around to grab 1, 2, and 3 in order. Number 1 is on a dash behind the plane of the board, and it's my right hand that wraps from 1 to 2 to 3 in order. My left hand wraps from 1 and then around to 3 to get back to 2. Since it was my right hand that wrapped from 1 to 2 to 3, that makes this an R stereocenter. With limonene, the hydrogen is pointed towards you as the viewer. From your perspective, you do the this guy pose. With number 4 pointed towards you, we check to see which hand curls to wrap from 1 to 2 to 3 in order. For this molecule, it's my right hand that wraps from 1 to 2 to 3. My left hand wraps from 1 to 3 to 2. Since it's my right hand that wraps from 1 to 2 to 3, this stereocenter is an R stereocenter. This method is a good one. It's the one I use. And it's a lot of fun on exams to see people curling their hands all over the place while they're writing the exam. The only reason I don't make it the official OChemNinja method is that it requires a trick, a hand trick, and not everybody can see that right away. So I'll again refer you back to the A.R.C method, the method I invented, the official OChemNinja method that assigns RNS stereochemistry every time, no matter what. It's linked in the description below. This video is one in a series of videos on alternative RNS labeling systems. If you like this method, keep it. If not, check out some of the other videos on labeling RNS. I'll see you in the next video.
Thanks for watching. The best way you can support this channel is to let your friends know about these videos, especially ones who go to different schools. Help spread the word around the country. As always, don't forget to like and subscribe.